Okay, this is Mrs. A with a recap of problem 3.4, using similar triangles to find a distance. You plan to cross a river and you want to know how far it is to the other side. So, how far is it to the other side? Let's see. What they're looking for is this line over here. How far is it to the other side of the river? We're looking for the answer to that line. You take measurements on your side of the river and you make the drawing shown. So question A is explain why triangle ABC and DEC are similar. So the definition of similar triangles we went over in class is, just get the blue, the definition is going to be the similar triangles have two congruent angles. They share two congruent angles. They have two angles that are equal between them. So if I look at triangle ABC, which is over here, BC, and I look at triangle DEC, I see that 90-degree angle over here, and I see a 90-degree over here. So the two of them share a 90-degree angle. So I'm going to write that down. So two congruent angles. I have, let's do that orange, I have a 90-degree angle. But I need more. I need one more. I need two congruent angles. So I have to get a little bit more wily. And so I'm looking at this picture and I'm trying to find ways to see if I can prove that another pair of angles are congruent. And what I notice is that if I look at this line and I look at this line, those are just two lines that are crossing each other. And whenever I have two lines that cross each other, I know that they create vertical angles. So do you remember what vertical angles are? Vertical angles are angles that are congruent. So we know that these two are congruent. We know that the two triangles do share another pair. So this guy is congruent with this guy. They're equal. So I've got my 90-degree angle and I have the pair of vertical angles. And that's my answer. I've proven that the two triangles are similar. So now let's go on to B. What is the distance across the river? So that's that yellow line we did over here with the X. What is that distance? So if we have two similar triangles, we learned earlier, I think it was back in chapter 2, that similar triangles, similar figures, they have proportional sides. So I just need to find out if I know that one triangle has a side of 60 feet, well then, and that triangle also has another side of 50 feet. I just need to find out that proportional relationship to the other triangle. So let's give this a try. So I've got my two triangles. I've got triangle 1, I've got triangle 2. Let's give this a try. So it's hard to see and look clearly at the sides. I like to redraw my triangles and I like to label them. So my first triangle is triangle 1. My second triangle is triangle 2. And I'm going to see what information I know about the two. Well, I know that they have a 90-degree angle, right? Both of them did. So let's do that. Oop. Let's try that again. 2, 3. And let's make another one. 1, 2, 3. There we go. So we've got two triangles and both of them should have a 90-degree angle. Let's give them both a 90-degree. Now the other thing they both have is vertical angles. So I'm going to look back at the picture and I'm trying to see if I turn the picture, if I rotate number 1, if I rotate it a little bit to the left, I see that that vertical angle is actually down here. Now let's look at triangle 2. If I rotate triangle 2 clockwise, if I rotate triangle 2 clockwise, I can get it to look like this guy. And I see that my vertical angle is over here. So all I'm doing is redrawing those triangles from that picture so I can just clearly label the triangles so that I can find their proportional relationship. So let's start to label now the side lengths. So if I look at triangle 1, I see I've got a side length of 50 feet. That's between the 90 degree and the vertical angle. So I can write that in. I've got 50 feet. And that's between here, right? There's my 90, there's my vertical angle. So I'm going to write 50 feet. Excuse me. And then I see I've got a 60 feet that's off of the 90. So I'm going to write 60 over here. So that's triangle 1. I've labeled it. Now let's go to triangle 2. So triangle 2, I can see the distance between the 90 degree angle and the vertical angle is 40 feet. So here's the 90 degree and the vertical, so I'm going to put 40. So all I'm doing is relabeling it, but I'm just using the notches in the triangle to help me label it accurately. And the side of the other side of that 90 degree I see is an X. So I'm going to put an X over here. So now I can start to see that proportional relationship. And we did really well on that chapter. So I want to just remember what we learned there and to come up with proportional relationships. And now I just look at the sides and I write ratios. So let's do that. So I have, let's see, so I'm going to do 60 to X. That's going to be one ratio. And I'm going to write 50 to 40. That's my second ratio. So remember, each ratio has to have a side from one triangle over the side of the other triangle. One side of one triangle over the side of the other triangle. And that's it. So now all we have to do is just use that butterfly method to calculate it out. To make a little bit more of a butterfly. Or you can use the baseball method, whichever works better for you. So I have 50 times X is equal to 60 times 40. And now I just solve for X. Okay, so I have 50X is equal to 60 times 40. 6 times 4 is 24. I've got 2 zeros. Okay, now I'm going to divide each side by 50. And the 50s cancel out on the left side. On the right side, I can cancel out one pair of those zeros. That gives me X is equal to 240 divided by 5. And at any point, you could put these into your calculator. I'm going to do some mental math here. So if I have X is equal to 240 over 5, that's going to give me X, let's see, is equal to 5 goes into 24, 4 times, remainder 40. 5 goes into 40, 8 times. I have 48 feet. Voila. So X is 48 feet. The distance across that river is going to be 48 feet. Make sure we answered the ask. What is the distance X across the river? The distance X across the river is 48 feet. Excellent. So that's it. Now, they give us the problem C, and I'd like you to try C. C is what if the distance from A to B is 55 feet? What if the distance from A to B is 55 feet? So we're looking A to B. That's this over here now. I see it was 60. Now it's 55. Why don't you give that a try and pause the video, and when you come back, I'll try to solve it and we'll compare our answers. Okay, so we're trying C now. What if the distance from A to B is 55 feet? What would the distance X be across the river? So I'm going to look at what's going to change. I'm not going to rewrite everything. I'm just going to look at what changes. So I have 60 is going to become 55 feet. That A to B for here is going to be from 60 to 55. So I'm going to change this guy now. It's going to become 55. So I can rewrite my equation. It would be 55 over x is equal to 50 over 40. Nothing else changes. So my problem, let's move them down here. So I can do my butterfly method. Here we go. And that gives me 50x is equal to 55 times 40. And 50x is equal to, you can get your calculator out. I'm going to just do a little mental math. I'm thinking that 4 times 50 is 2,000. I'm thinking 4 times 40 times 50 is 2,000. 40 times 5 is 200. So it's going to be 2,200. Also thinking, is that logical? If I look back to the original problem up here, thinking, well, it used to be 2,400, and now it's 2,200. It used to be 60, now it's 55. That makes sense. It's a little bit less. So I'm happy so far with my math. Now I'm going to divide each side by 50. X is equal to, the 50s cancel out. I can also take out a 10. I can factor out a 10 from the top and the bottom. And that gets me to 220 divided by 5. And that can be further simplified. You can get your calculator out, or you can do some mental math, and do some long division, whichever makes the most sense for you. I have 5 goes into 22 4 times. Remainder 2. 5 goes into 20 4 times. 4 times. And that's 44 feet. So again, I think logically, doesn't it make sense? If one of the sides became smaller, yeah, my x value became smaller. So yeah, I think it does make sense. So what would be the distance x? It would be 44 feet. I so hope that was helpful. And if you're still not so sure, let me also share this. You can always pause this and take a look. This is what's written in the book, Big Ideas. It also gives you the answer a little bit shorter than Mrs. A went over it, and I hope that helps. Have a wonderful day.